Hello everyone. Today we're going to learn how to balance redox reaction. So we're going to relate this to oxidation reduction, which is transfer of electrons. And we're going to use oxidation number to balance the redox equation. And we're going to use the oxidation number method for the net ionic redox equation to balance it. Okay, and the review is the net ionic. Net ionic equation is the equation that fully participates in the reactions. Only the ones that participate in the reactions. Here are the new terms. Now, in order for us to balance a reaction, we have to take into consideration electrons. This is what redox is all about.
Oxidation number method. The technique that can be used to balance more difficult redox reactions, based on the fact that the number of electrons transferred from atoms must equal the number of electrons accepted by other atoms.
So we're going to take into consideration oxidation reduction half reactions, and then we're going to balance the overall reaction.
Species. Any kind of chemical unit involved in a process.
Okay, chemical units. So there are chemical units that give up electrons and species that accept electrons.
Half reaction. One of two parts of a redox reaction. The oxidation half, which shows the number of electrons lost when a species is oxidized, or the reduction half, which shows the number of electrons gained when a species is reduced.
Okay, oxidation, loss. So you will see the electrons on the product side. Reduction is electrons gained, which you will see the electrons on the reactant side. Okay, we're going to work on some practice problems. And you have to read it carefully though, because some of them you want to oxidation numbers for each element, and some are oxidation number for the highlighted elements. So in this case, determine the oxidation number of each element. KClO3 is potassium chlorate. So potassium we know is +1 because it's in 1A and it loses 1. Oxygen is always -2, but we have 3 of them, so it's -6. So -1 plus x minus 6 equals 0 because the overall charge is 0. And then we solve for x. To solve for x, we move everything to the other side. -6 goes to the other side, is going to be positive. +1 to the other side is going to be negative. +6 minus 5, I'm sorry. +6 minus 1 is +5. So to summarize, K will be +1, oxygen is -2, and chlorine will be +5. SO3 negative. So now we have a charge right here. We're going to set everything up to equals to -2 because that's our charge. Sulfur we don't know. Oxygen we know it's always -2, but we have 3 of them. So x minus 6 equals to -2. Solve for x, so we bring or add 6 to both sides, and that gives us +4. So S is +4, oxygen is -2. Determine the oxidation number for the boldface element in the following formulas. Okay, so I'm going to do a couple of these. The first one is sodium chlorate. So sodium, we know it's always +1. We're not so sure about chlorine because they're asking for it. And oxygen is always -2, but we have 4 of them. So +1 plus x -8 equals to 0 because the overall charge is 0. And then we solve for x. So we add 8 to both sides and subtract 1. 8 subtract 1, and that will give us +7. So Na is positive, oxygen is -2, and chlorine is +7. All right, this one, when we have a charge, we set it up to +1. So X, which because we don't know N, hydrogen is 1, but we have 4 of them. So X plus 4 equals 1. We subtract 4 from both sides, so X is -3. Hydrogen is 1, N is -3. Chlorate is we don't know, so we put X for chlorate. -8 equals the charge, which is -2, and then we add 8 to both sides, so X is +6. Okay, now this one using the half reaction method. You're given a reaction like this, and then you want to look and see which one changed charges. So iron, when it's by itself, is 0, and then iron is +3, and then copper goes from +2 to 0. So these are the two that has the given up and accepting electrons. Okay, so now when iron goes from 0 to +3, it has 2 right in front of it, so that means 6 electrons were lost. Now for this one, for copper, it has 2 electrons gained because it went from +2 to 0. To balance the charges, which is 6 and 2, we multiply copper by 3. Sorry. And that gives us 6 and 6 electrons, and then we cancel them out. So 6 and 6, we cancel them out, and then balance the reaction. So we have 2 iron, 3 copper, gives us 3 iron and 2 copper, so they're balanced out. And this is the overall reaction. I think I have another example that might show it better. All right, we're going to use the oxidation number again. So we look at this one, we have, we do what we did for the first examples, just find the oxidation number for all the elements involved. And then find out what's going on. So copper here goes from 0 to +2. And then nitrogen goes from +5 to +4. So in this case, copper went from 0 to +2. That means it lost 2 electrons. So this is my oxidation. And copper is the reducing agent. And then for nitrogen went from +5 to +4. That means it's gained 1 electrons. This is my reduction, and it's an oxidizing agent. So to balance 2 electrons and 1 electron, so we multiply nitrogens by 2. So here's my nitrogen by 2, electrons canceled out. But then we take a look here, we see that on this side you have 2 nitrogen, but on this side you have 2, which is on 2 on the parentheses, so 2 plus 2 is 4. So if 2 plus 2 is 4, then we multiply this one by 2. I'm sorry, this one by 4, but when we multiply HNO3 by 4, hydrogen change, so 4 hydrogen going into 2 hydrogen right here. So we multiply water by 2. Now they're all balanced. Everything is balanced. 1 copper, 4 hydrogens, 4 hydrogens, 4 nitrogens, 2, and 2 is 4 nitrogens. Now when you multiply 4 times 3 is 12, and then we have here 2 plus 4 is 6, times 6 is 12. So everything is balanced. So first we balance the half, and then the overall we do it one element at a time. I hope that helps. Let me know if you have any questions. Thank you, everyone.